Exceptions are a very wonderful way to handle issues of errors. Let's take a look at a quick example. For example, let's multiply 2 by 0. Let's divide 2 by 0. You'll get this very terrible error, division error. Let's try to do a bunch of things. You may have already discovered the int function is something that will convert something in a string into an integer. So for example, that is an integer that gets converted. When you test for the type of that number inside of quotes, you'll notice it's a string, but when you just test it individually like that, you know it's an integer. What happens if we try to convert something like that into an integer? You get such an error, a value error. You might run into this when you say start working with input IO, where you're expecting some kind of input from people, and then you want to convert it into something usable. If you don't handle this well, you probably will get an error. Now, the way we handle exceptions in Python is we will start off with a try, which is a statement, and then we'll do something. For example, let's say x equals 3 by 0, and then go back a little, type except. Except is what happens when the code in between try and of course except fails to run. So let's have a message. These errors out. Sorry. And voila. This is far more graceful than doing something like that. And it's one way programmers will communicate many times. Your errors won't have issues. However, there's one thing that you have to know about exceptions. Exceptions, it's more preferred to have them very specific. So we should ideally do something like this. 3 by 0, and then type except, and then provide the name of the error. In our case, the error happens to be a zero division error. And then this way we can narrow down. Now, there could be much more errors that could possibly occur in a computation. So that's why you have to be very explicit when defining your errors, and this is a more preferred way of doing it. The ordinary except way kind of blasts off every possible error and just stops there. Here we can narrow it down. You can't divide any number by 0. See? This could also be wrapped in a function. For example, let's have a divide function where x is divided by y, and then we try to return such a value. Okay. Then here, in case it's a 0 exception, in case someone puts a value for y as 0, you can say something like y can't be 0. Choose correct value for y. When you try the same thing, 3 by 4, you'll get a value. That's right. 8 by 4, we should get 2. However, when we get 8 by, say, 0, oops, my bad. So it's always try to write your stuff with the correct names. So we got this error because there's nothing called zero division. So I'll have to kind of repeat everything I've done. Let me quickly write that. We try to return a division. Right, this is not true division. This is just integer division. That's why in our previous case we instead of getting a decimal or a float, we got something that was truncated. The decimal part was left behind. So it's supposed to be zero division error. Then we can say y can't by 0. Okay, so when you get that, you'll see that we get some nice cool looking error instead of the usual error. So I'll encourage you to play around with this, try exceptions. My usual trick is I try to do a computation on my shell, like here, and then I get the name of the error, and that's what I'll use in this place in except. I hope you enjoy the next couple of sections where we'll be exploring a lot more usage of such cases here.